Okay, let's start with limit as theta approaches 0 of sine square root 2 theta over square root 2 theta. We're going to let x equal square root 2 theta, and as theta approaches 0, x approaches square root 2 times 0, which is just 0. So I'm going to make the substitution. So instead of saying limit as theta goes to 0, I'm going to say that x approaches 0. And now I'm going to replace sine square root 2 theta as sine x, and then the bottom is also x. And we know that limit as x approaches 0 of sine x over x is just 1. Let's do a similar one. I have limit as t approaches 0 sine kt over t. This is not in the form sine kt over kt. So what I'm going to do is I'm going to multiply the bottom by k, but then also multiply the top by k. So now I can let x equal kt, and as t approaches 0, x approaches k times 0, which is just 0. So I can replace t with x, and that approaches 0. And then I still have a constant k, and then it's going to be sine kt is just sine x over x. I then can pull out the k. I have limit as x approaches 0 of sine x over x. And we know that sine x, the limit of sine x over x as x approaches 0 is just 1. So my answer is just k. Okay, let's do a little more complicated problem. Let's say we have limit as y approaches 0 of sine 3y over 4y. Well, first, I would like to have this 4 over here to be 3y, because then I could just make a substitution and I'll basically have sine x over x. So I'm going to have a 3 in the denominator. So I'm going to put a 3 in the denominator, and then I'm also going to have to put a 3 in the numerator to cancel it out. And this 4 will have to just come out. So let's see how that looks. So I have the 4, 1/4 actually, outside. And then I have limit as y approaches 0 of 3 sine 3y over 3y. And then I'm going to also take this 3, so this 3 over here also wants to come out. And I can also make a substitution and say that, well, let x equal 3y. So as y approaches 0, x will approach 3 times 0, which is just 0. So let's take out the 3 first. So we have 3/4, and then limit, instead of y approaching 0, we're going to say x approaches 0. And we have sine x over x. We know the limit as x approaches 0 of sine x over x is 1, so this will just be 3/4. Okay, let's do another one. We have limit as h approaches 0, now this time from the left, of h over sine 3h. Ideally, I would love to have a 3h at the top. But if I put a 3 at the top, that means I have to put 3 in the bottom to cancel it out. So then I'm going to have limit as h approaches 0 from the left, and I have 3h over sine 3h. And I could just take out the 3 in front. So this 3 could just come out. And now I can think of this, well, I can think of 3h over sine 3h as 1 over sine 3h over 3h. So 1 over the reciprocal is the same thing. Okay, so you're basically applying the reciprocal twice, and you get the same thing. So 1 over the reciprocal is the same thing. And now I can say, okay, let x equal 3h. So as, oops, not as x, so let's fix that. As h approaches 0 from the left, x is going to approach 3 times 0, which is 0. So you can really have 1/3, and then limit as h approaches 0 from the left. We can also just say 0 from the left as well. Doesn't really matter. Of 1 over sine x over x. We know that this limit, sine x over x, approaches 1. So really we have 1/3 times 1, and so our limit is 1/3. Let's do another one. This time let's involve tangent. So we have limit as x approaches 0 of tangent 2x over x. We can change tangent. We know tangent is sine over cosine. So we can say tangent 2x is sine 2x over cosine 2x, and then that's all over x. Now, since we're dividing by x, that's the same thing as multiplying by 1 over x. So really, that's just going to, this x is just going to come over here. So dividing by x is the same thing as multiplying by 1 over x. So that's why the x is going in the denominator. Okay, so we have limit as x approaches 0 of sine 2x over x times cosine 2x. And now I can break up this limit into 2. I can say limit as x approaches 0 of 1 over cosine 2x. And then I can think of it as another limit times limit as x approaches 0 of, let's see what's left. We have sine 2x over x. Okay, so for the first limit, if we plug in 0 for x, we get 1 over cosine 0, which is just 1. And now for the second one, we can multiply top and bottom by 2 to get limit as x approaches 0 of 2 sine 2x over 2x. And by now we know that sine 2x over 2x approaches 1. So this really becomes 1 times this 2, and then times 1, which is just 1. So our limit is 2. Okay. Now let's see what happens if tangent is in the denominator. Let's take a look at an example like that. So let's say limit as t approaches 0 of 2t over tangent t. I'm still going to change the tangent as sine over cosine. So I'm going to have 2t at the top, and then I have sine t over cosine t. And since I'm dividing by sine over cosine, that's the same thing as multiplying cosine over sine. So really, what happens is this cosine comes out in front, right? Because if you divide by sine over cosine, that's the same thing as multiplying 1 over sine times 1 over cosine, times 1 over sine. Sorry, same thing as just flipping it. Let's just keep it simple. Okay. So let's see how that looks. We have limit as t approaches 0. And now it's 2t times cosine t over sine t. Well, I can take the 2 out in front, and I'm left with t over sine t times cosine t. I can rewrite the t over sine t as 1 over sine t over t. And that's going to be times cosine t. And now we know that this limit right here goes to 1. Cosine t, so as t approaches 0, this also goes to 1. So we just have 2 times 1, so our limit is 2.